Welcome back. So in the business intelligence realm, it's hard to find data that doesn't have some kind of date component. If you recall, our data model does have a so-called calendar or date table that has one row per date and spans our time frame of interest. But thus far, we haven't done very much interesting with this table, other than relating it to the data tables in our model. But that's about to change, thanks to DAX's time intelligence functions. These time intelligence functions in DAX allow us to perform date-driven analysis. Things like year-to-date sales, or month-over-month comparisons, or 30-day moving averages, just for example, far more easily than you could otherwise. So as you can see here in our finished example file, we're going to tackle displaying year-to-date revenue totals alongside the individual monthly totals. So if you look at the line in our pivot table for December 2018, for example, you'll see that in our revenue column, we have just the revenue for that particular month. But in our revenue year-to-date column, we have the revenue effectively for the entire year, or at least the part of the year we have data for from July to December, because that's the revenue year-to-date for December. Now, while DAX's time intelligence functions are going to make creating this metric pretty straightforward, we have a little bit of setup to do before we start using time intelligence functions. So let's dive into that. So while we have our dates table created, it's important to emphasize the central role that the dates table plays when it comes to time intelligence functions. Having a table like this, which has one row per date and whose date range spans the date ranges of all the data tables in our model, is absolutely essential. We basically can't use time intelligence functions without a date table like this in our data model. Now, furthermore, this date table has to be related to the data tables in our model. And if you recall, and we'll confirm this by going to our diagram view, our dates table is in fact related to both our service calls table and our orders table on date. But there's one additional step we need to take before this dates table can be used as the official dates table for our data model. And that is to designate it as the date table for our data model. So if we go to the Design tab of this window, you'll see there's actually a button that allows us to mark this table as a date table. That lets the data model know this is our date table, which will be used as the basis for all these time intelligence functions we're about to explore. And while I could go ahead and do that, another option that we're given is to create our own date table from scratch right here in the data model. So if I click that button, you'll see we have the option to create a new date table. So let's see what happens if I do that. So after waiting a moment for Excel to finish its work, you'll see that we have a brand new calendar table structured very similarly to our previous one with one row per date, and with a number of derived columns that Excel was kind enough to tack on by default, including some of the same ones that we derived ourselves when we were creating our previous dates table. Now, while, as you can see, Excel gives us a lot of stuff here right out of the box, from the general structure of the table to these various derived columns, there are also a number of ways we can configure this table to meet our own needs. For example, if I click this date table button again, and then choose Update Range, you'll see that I have the option to change the range of dates encompassed by the table. But Excel was actually clever enough to look at our data and correctly guess an appropriate date range for this table. But if for whatever reason you ever wanted to extend, for example, the end date of the date range, it would be as simple as using this calendar picker in the date table range dialog box. We can also add derived columns to this table, just like we did our previous dates table. And if we go back to our previous dates table, you'll see that we have a couple of derived columns that were not automatically generated by the data model. So let's go ahead and port these formulas that generate these columns over to our new calendar table. So first I'll copy over our weekend column. So I'll copy that formula, go over to our calendar table, and then calling this column weekend. The only change I'll have to make is updating the reference in our if statement from pointing to the day name column in our dates table to the day of week column in our calendar table. And now I should be good to hit enter. And then for our quarter column, I'm actually going to show you a different way to derive quarter using a DAX function called format. So the format function takes in a value as its first argument, which in this case will be a date, and then for its second argument, it takes in a format pattern, which tells the format function how we want to format that value we fed it in the first argument. So if I want to create a column called quarter, I'll click under our add column heading, type quarter, equals, and then format. And then the value we want to format is the date column in this table. And now for the second argument, we'll tell the format function how we want this date to be formatted. Now we want it to be formatted as a quarter, so we'll just type in double quotes the letter Q for quarter. And then hit enter to lock it in. And as you can see, our formula is returning the number of the quarter corresponding with the date in each given row. Now, because the format function returns a text string, we can actually concatenate a capital Q in front of this number to make for a nice viewer-friendly quarter value. So before our format function, I'll type a capital Q in quotes, and then glue that to the output of our format function with an ampersand, and then hit enter to lock it in. Awesome. At this point, we have successfully replicated our previous dates table with just a few clicks. So now the last step is to retire our dates table and then replace any references to it with our new calendar table. So I'll go back to our dates table and right-click and try to delete it. But now Excel is telling us this table was created by a query, so in order to change it, we need to change the query instead. And that's because we originally created this table based on an import we did through Power Query. So we'll have to go to Power Query to get rid of the table. So closing out of our data model, we'll go to the Data tab on the ribbon, then Get Data, launch Power Query Editor, and now we'll simply right-click our dates table and delete it, and then close out of Power Query. And now we'll go back to our data model. And now our first step is going to be to tie our new calendar table to our two data tables in the same way that our dates table was formerly. So we'll go to our diagram view and then zoom out just a bit. And now you'll see our calendar table kind of isolated over here to the right because we haven't yet defined any relationships to it. So we'll drag it back to roughly where our dates table was, and now just create relationships between that table and the order date field of our orders table, and also the call date field of our service calls table. All right, so now that our calendar table is fully integrated into the data model, let's go back to Data View and see if we have any errors for any of our measures. Well, if we look at our service calls table, we'll see a little warning sign. So let's click that tab, and then scrolling up through all of our measures, we'll see that 2 display that warning, and if we hover over them, show us an error. But looking at the formula for the measure, it's pretty clear what's going on here. This measure is referencing the quarter name field from our dates table, so all we have to do is replace that reference with the quarter field from our new calendar table. And then hitting enter. And it looks like all of our errors have disappeared, so our calendar table at this point has fully replaced our former dates table. And because we created that table as a date table in the data model, our data model is aware of that table as our designated calendar table, which can be used to power our time intelligence functions. So at this point, at long last, we're ready to dive in and get our feet wet with time intelligence functions. So for our first step, let's create a simple pivot with year and month on rows and revenue on values. So I'll go to Insert, Pivot Table, from our data model, and then I'll drag in the year and month fields from our calendar table. And if you recall previously, when we dragged month name into a pivot table, the months were sorted alphabetically and not chronologically. But because our calendar table is now a designated date table, Excel recognizes those date names as things which should have a natural chronological sort order and sorts them that way instead of trying to sort them alphabetically. Just another perk of having a designated date table as opposed to just a table with dates that we use that way but isn't designated as such. So now I'll drag in our revenue measure. And now our goal will be to create a revenue year-to-date measure, which next to each month will show the total of the revenue for that year that that month belongs to up to that month. So for July of 2018, we should see the same total as July since that's the first month we have data for in 2018. But for December of 2018, we should see the year-to-date total for that year since that's the last month of the year. So to accomplish this, we're going to use a function called dates year-to-date, which is actually a member of a family of time intelligence functions, which all do something quite similar. There's also a dates month-to-date function and a dates quarter-to-date function, for example. So typically, you're not going to use dates year-to-date or any of its sibling functions on their own. Instead, you'll use them in the context of a calculate function to manipulate the filter context in that calculate function, kind of similar to how we saw the all function work previously. So here's how dates year-to-date manipulates filter context in calculate. It basically identifies the latest date in the current filter context. So for December 2018, that would be December 31st, 2018. It then expands the filter context backward to the beginning of the year that belongs to that particular date. So for the row of our pivot table corresponding to December 2018, our dates year-to-date function will yield a filter context that ranges from December 31st, 2018 all the way back to the very beginning of 2018. Now we only have data starting in July, so effectively it will allow us to sum those totals starting from whenever we had data in 2018 all the way to December 31st. Likewise, to look at another month, for example, say April of 2019, the dates year-to-date function is going to give us a filter context ranging from April 30th, 2019 all the way back to January 1st of 2019. So now that we know basically how dates year-to-date works, let's see it in action. So first I'll go to my Power Pivot tab and then create a new measure, and I'll assign it to my order details table, and I'll call it revenue year-to-date. Now for my formula, I'll start with a calculate function, and then the measure or expression that we're calculating is just going to be revenue, because what we're really doing here is taking that revenue calculation and just applying a different filter to it so that we see year-to-date revenue in our pivot table instead of just revenue for a particular month. And now for our filter, that's where our dates year-to-date function comes in. So we'll type that out. And now you can see that we have one mandatory argument and one optional argument. We won't worry about the second argument for now. Most of the time, you're good to just enter the very first argument, which is dates. So with dates year-to-date, as with the vast majority of other time intelligence functions, the first argument is going to be the column from our date table or calendar table that has the actual date values. Remember when I said that our date table is absolutely crucial for our time intelligence functions to work properly? Well, this is an example of how. They need that column of dates in our date table to work. So we'll enter that column. And again, that's the only mandatory argument for the dates year-to-date function, so we'll close our parenthesis for that one, and then our second parenthesis for our calculate, and then we'll format our measure as currency, and then click OK. And looking at our resulting values, it seems like our measure is working as it should. But let's just test a few months to make sure. So rolling forward to 2020, for January, our revenue value and our revenue year-to-date values are the same, as you would expect. But if we go forward to, say, August, we see that our monthly value, our value for that 1 month in 2020, is $599,000. But if we sum up the values ranging from January 2020 all the way through August 2020, and then look down at the automatically generated totals in our status bar, it looks like they match. The sum of all of the individual monthly totals in 2020 through August is around 2.8 million, and that's also the number we get for August in our revenue year-to-date measure. Now, there is one issue here that I have not pointed out yet that you won't see until you scroll to the bottom of the pivot table, and that's that once we get past the last month in the last year for which we have data, our revenue year-to-date measure keeps populating, even for months where we have no data. That's because, for these months, the concept of year-to-date revenue is technically still valid. You could accurately say that as of November, the year-to-date revenue total is 4.6 million, just as it was in August, the last month we have data. But while this is technically accurate, it's not really a great user experience and would probably be confusing to most end users. So what we need here is a way to conditionally make the output of our measure blank if the underlying revenue measure is blank. Now, there's a fairly straightforward way to solve this problem, but this video has already gone a little bit long, so we'll tackle that in the next one. I'll see you then.